All right, so our next step is to do a review from Algebra 1, in theory, about how to simplify exponents. So there are 7 basic rules. So what I'm going to do is I'm going to go over all the rules for how we simplify them, show you kind of a concrete example of each rule and how it works, and then give some tips and tricks for how to actually know when you're done simplifying exponents and how to approach the problems. All right, so rule number 1 for simplifying exponents. If you have 2 exponents to different powers and they're multiplying each other, that would mean that we would add them together. So that would be a to the m plus n. So looking at this rule as a concrete example, say we had 3 squared times 3 to the 4th. If we were to actually write those out, 3 squared would mean 3 times 3. 3 to the 4th would give us 4 more 3s. If we simply counted them out, we'd end up with 6. So this is why we're adding the exponents. So that'd be 3 to the 6, and we could actually get a number for that. That's what? 3, 9, 27, 81, 243, 729, something like that. So that's our first rule. Second rule, our next basic one. Again, if we have the same base still, and they're dividing each other, when we look at this, we're actually going to subtract the exponents. So it's a to the m minus n. Again, if we were to look at a more concrete example for this, say 3 to the 5th over 3 to the 3rd, if we were to write them out, that would be 5 3s on top and 3 3s on the bottom, and we'd actually cancel them out. The net result being that we have the 5 minus 3 gives us an exponent of 2. So those are kind of our 2 basic rules. They're the ones that show up the most often. They're the ones that we have to use the most. Next rule, negative exponents. So this would be like a to the negative n. All a negative exponent does is it moves that term's location in a fraction. So if we had a to the negative n, that would become 1 over a to the n. If we had a negative exponent in the bottom, then that would move it up to the top. So again, all a negative exponent does is it moves it around, and it only moves that particular term. So if I had a over x to the negative 3b, as an example, just a whole bunch of weirdness going on, the a and the b aren't negative, they're not going to move around. The x to the negative 3rd will move. The negative says it's going to move up to the top, so we'd have a x to the 3rd over b. So the x to the 3rd, the negative moved it to the other part of the fraction, and then it became a positive. That's basically what that rule is saying, is that whenever you have a negative exponent, it's going to change its location inside of the fraction. Now, let's see if I can actually remember all these rules off the top of my head. Rule number 4. So exponents actually distribute across multiplication. If we have several things inside of parentheses and an exponent outside, that exponent is actually going to go to each thing inside. So that'd be a to the n, b to the n. As an example, if we had something like 2x to the 3rd power, that'd be 2 to the 3rd x to the 3rd, so we'd have 8x cubed. Just like exponents can distribute across multiplication, they can also distribute across addition. So if we had something like a over b to the n, that n is still going to go to each thing inside of it. So that gives us a to the n over b to the n. Again, concrete example would be like 3 over x squared. That'd give us 3 squared over x squared, which would be 9 over x. Okay, that's 5 rules. We've got 2 more to go. Okay, rule number 6. And honestly, the numbers don't really matter so much. If I have something to a power and I raise that whole thing to another power, we are going to multiply those powers together. So if I have 2 to the 3rd squared, 2 times 3, 6, that's going to be 2 to the 6th power. And finally, our last rule, I actually remembered them all, is almost anything to the 0 power is just 1. If you ever want to know why, it has to do with the fact that 1 is the multiplicative identity. It doesn't change things when you multiply by it, so it has to do with that. If you ever want more details, I can give them to you if you want. So those 7 rules basically form our basis for how we simplify things. So again, same base, you simply add the tops. You add the exponents together. Note that you don't multiply the bases together. 3 squared times 3 to the 4th is still a 3. If we have the same base with different exponents and it's all dividing, we subtract them, top minus bottom. Anything with a negative just moves it from top to bottom or from bottom to top inside of a fraction. Exponents distribute across multiplication and they distribute across division. Finally, if we have something to a power raised to another power, that means we multiply them, and anything to the 0 is 1. So those are the 7 rules for simplifying exponents that should be at least somewhat familiar, hopefully, from Algebra 1. Now, all of the homework questions basically has told you to simplify things. So when we go to simplify, there's a couple quick rules to help you realize if you're done or not. 1, there can't be any negative exponents left, so no negative exponents. If you still have negative exponents, you are not done with the problem yet. 2, generally speaking, there should be a single letter for each letter, or a single letter of each type. So we shouldn't have an A on top and an A on bottom. You shouldn't have multiple A's on one side of the fraction. We just need to get down to a single letter. And then finally, actually simplify the numbers. If you're going through the problem and solving it and you have 3 to the 3rd, that's 27. So your answer should be 27. Don't give it to me as 3 to the 3rd. So simplify numbers. Now, there's not a lot of rhyme or rules as to particularly how you have to approach these problems. As long as you follow the guidelines and you take it a step at a time, you can do them in pretty much any order. The only thing that's really important is that you do grouping symbols first. So let's do 1 or 2 examples and then we'll call it there. So let's say I had 2a squared b to the negative 2 over a to the negative 3b. All right, so this is kind of a big mess. We need to simplify it. So the first step that we have to do is we have to deal with this grouping symbol. So remember that exponents distribute to everything, so I'm going to do that first. So that gives me 2 to the negative 2. Let's see, negative 2 times 2 is negative 4, so a to the negative 4, b to the negative 2 over a to negative 3b. So all I did is I distributed first. Now from here, honestly, it's kind of up to you. My personal preference for dealing with these things is next, I tend to get rid of negatives. I'll move anything that I need to move because I find that a lot of people will make mistakes dealing with negatives in these scenarios. So sometimes it's easier to just deal with all the negatives. So anything negative, I'm going to move to a different part of the fraction. So the 2 would move down to the bottom as a 2 squared. This a to the negative 3 would move up top as an a cubed. This a to the minus 4 would move down. This b down here would stay. This b to the minus 2 would come down. So all I've done is I moved them all. Oops, there's a positive too. Is I moved them all to get rid of negatives. From here, there's a bunch of different ways you can approach it. You can do simplify top, then simplify bottom, then do any canceling. You can deal with individual letters at a time, which is how I tend to approach it. You can deal with numbers and individuals. It doesn't really matter. So for me, myself, let's deal with the numbers. 2 squared is a 4. No other numbers, I'm done. If I look at the a's, we have a 3 on top, a 4 on the bottom. So that would be a to the 3 minus 4 is a to the minus 1. So that would move it down to the bottom. So I'm going to have a single a to the first in the bottom. B's down here, I have a b to the first times a b to the second. So that'd be a b to the third in the bottom here. And then since there was nothing left on top, we just have a 1 placeholder, and this would be my answer. So notice we double check, no negative exponents, check. Single letter of each type, check. Numbers are simplified. So this would be simplified all the way through. Again, there's not a lot of guidance as to what you have to do in what order. From here, we could have done -4 minus -3 is an a to the -1. We could have done -2 minus 1 is a -3, and then gone that way. We'd still end up at the same location. So just kind of try it out, play around with it. I think we'll leave it at that one example for the moment. And then make sure you're applying the rules properly as you go.